Okay, welcome back. These are the Mod 15 Part 1 notes. This is page 7. A couple of examples here. Example 7, suppose we conduct a hypothesis test and conclude our null hypothesis was true. What can you say about the type of variation found between the two groups we were testing? We are going to say that the differences are due to a random variation. Which means while it may not be exactly the same as our population mean, or it may not, or it may be what seems like a good distance above, because of sampling, we still believe that the variation is typical for our population. Example 8, suppose we conducted a hypothesis test and concluded our null hypothesis was false. We are going to say then we believe that the differences are due to systematic variation. Which means there is something different about this sample, different from the population as a whole. We are going to use probabilities, what we know about probabilities, to determine whether or not these variations are random or systematic. We've got two different ways to do this. We have something called the p-value approach, where we compare probabilities directly. Or we compare the level of significance. Sometimes this is called the critical value method. So think back to our normal distributions. Every raw score had a z-score associated with it, and that z-score cut off a percent or part of our curve to the left. That was our probability. So these both do the same thing, just different methods. You want to be comfortable with both. Okay, so we have our level of significance. That is our alpha, and we saw alpha before. That was 1 minus our confidence level. Okay, here that alpha level, or the level of significance, is going to be given to you. We are going to look for the 5% or the 1%, and we will see examples of that coming up in the next couple of pages. So if the p-value is greater than our level of significance, that means that the p-value that we are testing for our value is not in that tail, doesn't have a probability that's less than that of happening. This is going to be random variation, and I am going to draw pictures of that normal curve as we move forward. That seems to help. If the p-value is less than our level of significance or our alpha, then we're going to say this is due to systematic variation. And we are going to look at our results as being statistically significant. So, and let me apologize in advance for the way this question is worded. Example 9, we're going to suppose in our Harvard problem, that the probability that our sample mean was as extreme as it was, assuming that the null hypothesis was true, put in a couple comments, had not crossed our threshold level. So it's not gone into the tails. To what type of variation do we attribute the difference we found between the Harvard sample mean IQ and 100? This is going to be a random variation. It's not so different that it is living in the tails.